All right, so like I said, today we're going to cover sections 3.1 and then 3.4 and then 3.3. So we're going to do those three. We've got some ground to cover today. So previously, chapter 2 was all about one variable equations. We were solving one variable equations and one variable inequalities. We did some absolute value stuff, but we were always just working with X or whatever the heck variable they picked. Chapter 3 and 3.1, we start dealing with two variable equations. These can also be called relations. Okay, because as you have more than one variable, they relate to each other, and affecting one has an effect on the other. So what you do to one variable has a distinct effect on the other. So they are related, hence relations. Okay, for example, if we had something like x plus y equals 5. Now, it doesn't always have to be x and y, but in math, algebra specifically, we will typically use x and y, and I'll show you why here in just a little bit. But you can see that when we have two variables, there is multiple solutions. The first way you probably ever learned to show this was using what we call an XY chart. And this just shows that as I pick one variable, that changes what this one has to be. So if my X has a value of 1, so if I plug 1 in for X, then Y would have to be 4 for this to work out, because 1 plus 4 is 5. So if X is 1, then Y has to be 4. They are related to each other. So again, that's what makes this a true statement. And if I change my X value, and I'm going to follow a pattern, okay, so if I make my X value a 2, okay, 2 plus what number is 5? We can solve for Y. Y would then have to be 3. And really, that's all you need. From those 2 points, you can actually show the whole solution. I'm going to do another one just because I like following the pattern. So if that's a 3, 3 plus 2 is 5. This is really nice. Now, this is not your only solutions, because not only could we keep carrying this pattern out forever in this direction, we could actually carry the pattern out in the opposite direction as well. If my X got smaller, I could do 0 and 5 or -1 and 6. Okay. Also, in between these, we have decimal points or fractions. We could do those as well. So like 1.5 and 3.5, or like 2.1 and 2.9. Okay. So there's tons, in fact, an infinite number of points. So instead of trying to list them all, when you're dealing with a two variable equation or relation, we will typically graph them on what's called the Cartesian coordinate plane, or a grid system, your axes. And in math, your x-axis is your horizontal axis, with 0 being here in the middle, and then your positive numbers going to the right, negative numbers going to the left. Y is your vertical axis, with again 0 being in the middle, positive numbers going up, negative numbers going down. And these extend infinitely in all directions. Now, again, the way these relate is anytime we have X and Y, which is why we pick X and Y due to the naming of the axes, okay, that gives us what we call an ordered pair, or a coordinate, and that gives location within the graph. So an ordered pair will always give you the X value first, and then the Y value second. So it tells you your horizontal location, then it tells you your vertical location. So the point 1, 4 goes 1 on the X, and then goes up to 4 on the Y. So like this next one, 2, 3 would go 2 on the X, 3 on the Y. 3, 2 goes to 3 on the X, and then say 2 on the Y. And again, if I did this accurately enough, you can see that it makes a straight line. And if I would keep following it out, in fact, if you had a grid, you could see this a little better, but the 0.41 would work, or 5, 0. So any point that falls on this line should give you a valid solution to this equation, including the fractions in here that we can't see. So like 2.5 and 2.5, okay, or 3.2 and 1.8. Okay, so even these little fractional pieces should still give you a valid point on the line. So it doesn't just have to be pretty little whole numbers. Now, I tend to use pretty little whole numbers just because it's easier to see, especially, like I said, if I was able to actually draw this accurately. And again, you're dealing with a sketch and a offhanded thing, but anyway, if I do my best, okay, you can see like an actual grid where these points fall neatly right on like where the points come together, and it's easy to identify. So the more perfect whole numbers we can use, the better. But anyway, all that to say that this line represents all of the valid X and Y coordinates that work for this specific equation. And as the equation changes, the direction of your line would change, and so on and so forth. And the more things you have going on, so a simple X and a simple Y, these points are pretty easy to generate. If we did something like this, it becomes a little trickier to find pretty little whole number solutions. Now, again, going back to probably the first time this was introduced, most teachers just start by giving you a couple of X's to try. You go 1, 2, and 3. However, this doesn't work out really well, as you'll see, because if I try plugging in a 1 value of X, okay, if I make my X value 1, I'm just going to show this. So 3 times 1 is 3. Okay, so if I want to solve for Y, subtract 3 from both sides. Negative 2y equals 3. So when I divide by negative 2, I get a fraction. So yes, you can just randomly pick an X and you can solve for whatever Y value would work. However, you might not always get something that's really pretty or easy to graph. Now, again, on a sketch, which is obviously what I'm doing here, this is obviously not going to be super accurate because I'm just hand drawing stuff. Okay, fine. If X is 1, Y is going to be 3/2 or 1.5. So somewhere between 1 and 2. So somewhere right around in there. And if you're just doing a sketch, then ballpark is going to be good enough. Okay, my math lab is not all right with ballpark. It wants things to be very specific and very accurate. So you want to find as many pretty little whole numbers as possible just because it's easier. And I'm actually going to walk through a couple to show you how my math lab has you graph, as opposed to, again, pencil and paper. Because like on mine, if you graphed 1, 1.5, that's fine. I can tell where that point is, and that's going to be close enough. Now, nice enough, if we pick the point 2 here, that one does work. So if I make an X value of 2, 3 times 2 is 6. Subtract 6 from both sides. 2y equals 0. Divide. Y is 0. So if X is 2, then Y would be 0. And like I said, as long as you know those 2 points are right, that gives you your line. All you need is 2 points. Now I'm sketching, and obviously you can see my line kind of tails off here. So trying to use this to find any other points would be really, really inaccurate. So this is just a sketch to kind of give you an idea of the line. If we needed to be more specific, we would need either better graph paper or make sure we hit on pretty little whole number points. We can, again, find that pattern. Now, what this does illustrate, though, is this is a very specific point that I want to talk about for just a second. Okay, when you get a Y value of 0 and you have an X value, that point is right here on the X axis. This point has a specific name. This is called your x-intercept. This is where your line intercepts or crosses the x-axis. Intercepts are nice because, again, they're easy to find because you can just make one of your values a 0. For example, to find the x-intercept, all I have to do is make the y 0. So kind of flip it. Instead of saying x was 2 and then, man, that happened to work out. If I did that backwards and made my y 0, so if I would have put my 0 here first and then solved for x, I would have solved and got that point. So I'm actually going to find this point next. I want to find my y-intercept. So same thing. If to find the x-intercept, I make y 0. To find the y-intercept, I'm going to make my x 0. I'll write it down here. It theoretically should be up here if you're doing things in order. But if I make my x 0, then 3 times 0 minus 2y equals 6. So 0 minus 2y is just negative 2y. Divide, divide. Y is negative 3. Oh, that's because I graphed it wrong. I was like, why did I get a negative number? It's because, all right, I'm dumb. See how that was a negative 3/2? I graphed it as a positive. So we're going to pretend I didn't do that because that point should be down here. Negatives are down here. So negative 1, negative 2, negative 3. There's negative 3/2. So my y-intercept is down here at negative 3. So if my x is 0, my y is negative 3, and that's my actual y-intercept, which again, the more points you have, the more accurate your line will be, because you might make a silly mistake and accidentally graph one in the wrong place. So that's why I did that. I did that to show what happens when you mess up at math. And then this is the correct accurate line. And again, this point where you cross the x-axis is your x-intercept. This point where you cross the y-axis is your y-intercept. So this is the point 2, 0. This is the point 0, negative 3. So in terms of graphing a line, these are 2 points that are typically pretty easy to find. And that's what I would typically use to graph, especially if you get pretty little whole number answers for both. I would draw those dots, connect those dots, and that's what you would need to do. Now, within 3.1, primarily what my math lab is going to ask you. So I want to talk about a couple of things specific to my math lab. The first thing they're going to have you do is they're going to have you test some coordinates. Not difficult. You just plug your x and your y in and see if it generates a true statement. So for example, they will ask, is the point 1, -5 a valid solution, or would it be on this line? Basically, does this work? What they're asking you to do is to plug this point into your function and see if you get a true statement. Now, this is where it's important to remember, this is an ordered pair. The first number is always your x value. The second number is always your y value. They do not always write them in order. So I'm going to do one in order, then I'm going to do one kind of out of order, but just to kind of give you an idea of what they're looking for. And again, what they're asking you to do. So we're going to replace our variables, our letters, with our values. So again, the 1 goes in place of the x, and our -5 is going to go in place of the y. And then we want to see, does this generate a true statement? Is that going to actually equal -3? Well, 2 times 1 is 2. 2 plus -5 is -3. Yeah, so it generates a good, true statement. So yes, this is a valid coordinate.
Question.
Answer.
So like on our test, do you want us to show, like if we have a question like that, do you want us to show the work?
No.
Okay.
This would be a simple yes or no question. Does this point work? Yes.
Okay.
Does this point work? Yes. Does this point work? No. So simple yes or no. Is it a valid point on the line? Yes or no? And while I showed the steps and the work on this one I just knew 2 times 0 is 0. I plug -3 in for y, -3 equals -3. 2 times 1 is 2. 2 minus 3 is -1. -1 is not -3. So if I show the work for this one, -1 does not equal -3. This is a bad point. That point would not be on the line. Let's do plus. All right, again, they may give you an equation and then ask, does this work? Is this a valid point? Would this point be on the line? Any of those things are questions they could ask. I don't know the exact wording they use, but basically, is this a valid point? Is this a valid XY combination that would work for this equation? Again, pay attention to your order. The first number is your X. The second number is your Y. It is always in that order. This is an ordered pair. Order matters because, again, this gives you your horizontal location. This gives you your vertical location. It's important for them to always be in the right order. But in this equation, we've got a Y here and then our X here. So make sure you put the correct number in for the correct variable. So what they're asking is, does 7 equal 1/3 of 6 plus 5? So 7 is just 7. 1/3 times 6. 1 times 6 is 6. Divided by 3 is 2. 2 plus 5 is 7. Yeah, 7 equals 7. This is a valid coordinate. So just make sure you're plugging the correct number in for the correct variable. Now, the next thing that MyMathLab throws in that I wouldn't throw in yet, but they do, is they also throw in some non-linear functions. Three one is mostly about linear functions. Everything we did, okay, 2x plus y equals -3, y equals 1/3 x plus 5, okay, x plus y equals 5. Okay, any of the problems that we have done have all been linear, meaning when you graph them, they make a straight line. If you just have an y and an x, it doesn't matter if you put numbers in front of them or numbers after them. If you just have a y and an x, your graph will make a straight line. And in fact, if you just have a y, that also makes a straight line. Or if you just have an x, that makes a straight line. I'll talk about those here in just a minute, but those are all examples of linear equations. Nonlinear is when you change the exponent or you throw in some crazy operation. For example, if I said y equals x to the second power, when you change the exponent, you change the shape of the graph. Your graph is no longer linear. Okay, linear graphs make a straight line going in some direction. When you square your x, you get this shape here, more or less. It's called a parabola. I'm not going to spend a ton of time on how to graph a parabola. That happens later. You just need to be aware that when you change the exponent, it is nonlinear. And if you need to match a graph, the x squared will go like so. If that's negative, then that actually flips the graph over. But anyway, another thing they may do is they may give you an x to the third power. X to the third power, graph's kind of like that. Talked about absolute value. If they graph an absolute value function, it makes a V. They give you a square root function. It looks like so. So all of that to say, they're going to have you graph some linear functions. They will not have you graph the nonlinear functions, at least not yet. We will get into that later. That's not a lesson for today. But they will have you match it. And I'm going to give you a couple of things that you can do that will help with that. All right, so for starters, like I said, I want to go to my math lab and show you what it looks like, or how they want you to graph things. So I'm going to open up my math lab real quick. I say real quick, last time I tried to do this, it took forever. So let's see if this plays nice. All right. So I need to share. Share screen on that one. All right, so hopefully everybody is seeing that 3.1 graphing equations. It says determine whether the equation is linear or not. And it gives you the equation y minus 3x equals 3. Is everybody looking at what I'm looking at? Okay. So the question is this linear or nonlinear? We just have a singular y and a singular x, no exponents, no crazy operation. So this is an example of a linear function. Fantastic. Thank you, my math lab. Now, when it has you graph, you have to graph on here, and it's not by a pen, it's a bunch of button clicks. So you can click on this tool to enlarge, or if you click within the graph, it's going to give you some options down here at the bottom. This is what you're going to use. When it's linear, you're going to grab the one that is a straight line. So if you can kind of follow my hand, little icon down here at the bottom. So this is linear. This V1, that's your absolute value. There's a parabola. Okay, that's for your x squared functions. And they actually didn't give us one for an x cubed or anything else. When we need to, they'll give you a button for those. But in this case, this one is linear. So you want to click on the linear tool. And then you've got to find 2 points that work. And wherever you click, it's going to drop a point. And then wherever you drop the second point, it's going to draw your line. Now, the good news is you can move those around. So if you meant to put it there or there, you can drag your points wherever you want them to be. And then whenever you're done, you click submit, and it'll tell you if you got your line right or wrong. If you need to zoom that in, you can zoom it in. So anyway, real quick, y minus 3x equals 3. If x is 0, then y is 3. So that's my y-intercept. If y is 0, negative 3x equals 3. So x would be negative 1. So my x-intercept is negative 1. That's the 2 points I would pick. You don't have to. Obviously, like if this line is correct, then the 0.16 would have worked as well. So say I picked those 2 points. Click on check answer, then I can see that I got the line right. So anyway, that's the mechanics for what this is going to look like. So for a linear function, I don't want that being right there. How do I move my deal? Ah, there we go. I can move that out of the way. So if I do another question, so again, just a y and an x, that's a linear function, and it brings up my graph. When you click on the graph, that's what gives you your options down here at the bottom. Again, for a linear function, you click on the line, then you just need to find 2 coordinates that work. And it'll draw your line for you. Now, for a non-linear function, we'll just do that one right there. Okay, can everybody see this again? Y equals absolute value of x plus 1.
No.
No.
You don't see that anymore? Okay.
No.
All right, let me go back and see what happened. All right. Put that back. I don't know what happened.
Yeah, I don't know about the other students, but I couldn't even see the graphed portion.
Okay.
Yeah. Same.
All right.
Couldn't either.
Well, let me try again, because when I tried to move stuff around, so I'll go back and try that again. So if I share, so it didn't show you the graph at all.
No. Like it just stayed on that page that you're on right now.
So this purple, so whenever I clicked, it didn't show you the next screen.
No.
That's ridiculous. I don't know any other way to do that. That's gonna be too bright. I was gonna try and move my document camera to show you, but I can't do that either.
Like that camera? Would that work?
As many technical difficulties as possible. So if I bring the Zoom camera around,
I
hold
mean,
on.
it's an option.
I know, I'm gonna try something. This is ridiculous. Ugh. This is me being low tech, trying to play high tech. Super meta, so we're picture in picture here. All right. So non-linear, I'll go back and do a linear function. So just a y and an x. That's going to be linear. Click submit. It's going to bring up my graph. When you click on the graph, there's your options down here at the bottom. I want the straight line one. And then I'm going to find 2 points that work. I'm going to pick x and y intercepts. Actually, I'm going to pick the y-intercept. I know that's -5. And then if x is 1, or -5 is -1, so then 1, -1 is also a solution. You'll also notice that as I was kind of moving around, you can see it'll show the actual location of where you're at here, which is kind of nice too. So if you're not sure if you're at 1 or 2, okay, it'll actually show the location of where you're at here. And then you can submit. For a non-linear one, so this is an absolute value. A non-linear function, they'll typically give you a matching question. Oh, come on. Give me one that I got to graph. There you go. Not linear.
Nope.
It should. Part 1 of 2. Go to part 2 then. Where's part 2?
You have to press continue.
Oh, it's blocked by something. There it is. Okay. Usually it'll give you a matching scenario. So this is why I kind of gave you those shapes. So when you see that this is x squared, okay, you know it's going to be one of these rounded parabolas, not one of the sharp V's. The sharp V's are your absolute values. So it's either going to be B or C. If you want, you can pick a point and plug it in. So if I plug in x of 1, That'll give me an idea that y would be -6. So at +1, I go down here to -6. Or remember, if I said if your x squared is positive, it's going to be facing up. If your x squared is negative, it's going to be facing down. But it's just a matching. So you're not going to have to actually graph those. Anyway, another thing that will also help you, at least especially for the homework, there is a website. DESMOS.com. Okay, Desmos.com. It's a free graphing utility, and you can type in whatever the heck you want, and it will graph it. So when we looked at that y equals -6x, and then to get to squared, I'm going to use my on-screen calculator. Okay, and then it'll draw the graph for you. So you can use that to check anything you need to check. Y equals x plus 5. I think it was one of the ones that I put on there as an example.
Yep.
And again, you can highlight points specifically. So if I think this is where they cross, okay, I can look. Yep, -2, 1. That's a good point. Okay. 0 and then 1 point. Now it's going to do decimals instead of fractions, but you can use Desmos to get an idea of what the line should look like. Now you can use Desmos for MyMathLab. I can't let you use it on tests and stuff like that, but it's a great tool to practice to make sure you're doing things right. Okay. If you're not sure, I don't want you to be like questioning anything, but this is a great tool to use to double check what something is supposed to look like. So anyway, that's just some of the mechanics that they're going to have you do. Hopefully I don't make everybody sick moving the camera around. I apologize.
It should be still showing that screen.
Yeah, and I'm going to go back and change it to my document camera. Okay. So anyway, that's just a little bit of how MyMathLab is going to have you do things. So the linear ones, they actually have you graph. You just got to plot 2 points and it'll connect them for you. When it gives you a nonlinear one, it becomes a matching problem. And typically, as long as you know the shape, that's really all you're going to need. When we need to get more specific about what the actual graphs look like, I'll go into more specifics, but for tonight and for this section, this is more than enough. So a positive x squared is an upward facing u. If this is negative, then that just takes it and flips it over. Okay, same thing. Absolute value bars, because it makes everything positive, is always that sharp V. And then a square root actually has a starting point and kind of goes up. It's kind of like this parabola turned on its side, and you don't get the bottom half of it. It's just like the top half of that. So that's just some examples of some non-linear functions. Now, I'm going to jump ahead to 3, 4, which 3, 4 and 3, 3 are more about graphing. So if I told you to graph, whoa, come on, focus back in. You can do it. There we are. Okay, something like this. We could do it, but finding whole number coordinates that work becomes a little more problematic. Okay, or, okay, again, once I introduce that math cuss word, once we introduce fractions into things, okay, finding individual coordinates is not a good solution for a lot of people. So another way we have to graph is using the slope of the line. So I want to talk about slope. Slope of a line is basically just a description of the line. It's the measure of steepness, if steepness is a word. Slope compares the rise to the run. The rise is how much the line goes up compared to how much it goes over, or down and back, or down and over. Okay, you can have a negative rise and a positive run, or a negative rise and a negative run. Anyway, we'll talk about rise over run, but that's just a description of your line. So again, a line with a positive slope will have a positive rise and a positive run. It'll go up and to the right, like so. So a line with negative slope will go down and to the right. We'll have a negative rise with a positive run. Now, there are two other concepts that we kind of need to talk about when we're talking about slope. Most lines, like 98% of the lines you're going to mess with, are going to be slanted in some way, shape, or form. And if they're going up to the right, that's positive, down to the right, that's negative. Okay. But it is possible to have a perfectly horizontal line. And then this line has a slope of 0. Because you have 0 rise, but you have some kind of run, and 0 divided by anything is 0. So a horizontal line has a slope of 0. On the other hand, a perfectly vertical line has a slope that is undefined. And the symbol for undefined is that 0 looking thing with a slash through it. Or you can write the words undefined. And it's the exact opposite. So we have tons of rise, we go up and down, but we have no horizontal run. This line doesn't go left or right at all. And you can't divide by 0. There's actually kind of a funny thing. If you have an iPhone or if you have some Apple device, you can ask Siri how to divide by 0. And it talks about Cookie Monster has 0 friends, and you try to divide amongst 0 cookies, and now you're sad because you don't have any cookies and you don't have any friends. Anyway, there's a funny thing about asking to divide by 0. But anyway, dividing by 0 is a concept in math that's invalid. It's impossible. You can't do it. So when you have 0 run, that's what makes it undefined. So just don't confuse these. In this case, 0 and no slope are not the same thing. So a horizontal line has a slope of 0. Vertical line has a slope that is undefined. Okay. Now again, in 3-4, they're going to ask you to find the slope. They're going to do this in one of 3 ways. The easiest, they will give you the line. They'll actually be on a graph somewhere. Okay. And they're going to ask you to find the slope. You can just literally count. So from one point to the next, you count your rise, put that on top. In this case, we have a rise of +2. Count your run. In this case, we have a run of +2. So we have a slope of 2 halves. Now, this is a fraction. And anytime we're dealing with fractions, if you can reduce, you need to reduce. So 2/2 reduces to just 1. Okay, so if they give you a line, you should be able to find the slope. Find 2 points and then count. So we've got a rise of -3. We've got a run of 2. So this has a slope of -3 halves. And algebraically, they call the slope m sometimes. So if they ask you what m equals, they're asking for the slope. That comes from a formula. But anyway, m is referred to as the slope. But if they give you the line, you can simply count. Count your rise, count your run. Now again, because it's a fraction, if you can reduce, you need to reduce. Now, do not make that a mixed number. So -3 halves as a fraction is -1.5. That is true. But when we're talking slope, we want rise over run, so we leave it improper. Don't make it a mixed number. Also, don't make it a decimal. while it's not technically wrong, it's also not technically right. So slope, we want to leave as a fraction or as a whole number. So this one would have a rise of 2, run of 4. So again, we would need to reduce to 1/2. Again, this is not wrong, but it's not reduced. I would only take half a point off for not reducing. My math lab counts the whole thing wrong. Now it will pop up a nice little box that says you have the right answer. Make sure your fraction is in simplest form. Okay, that's just a key that says, oh yeah, hey, remember to reduce your fractions.
It also gives you like a second chance to check your answer too.
Yeah. When it's something like that, it's kind of nice that it does that. It's like, are you sure you meant to do this? Because it's not quite right. Now, similarly, they can give you coordinates. So instead of actually drawing the lines, they could ask, what is the slope between these two coordinates? And as long as they're small or close together, you could graph those and count exactly like we did. However, if they did something like the point 20, 100 and 5, negative 100, where they're going to be spread way far apart and counting just becomes like a nightmare, okay, we can actually have a formula as well. So the formula for slope is y2 minus y1 over x2 minus x1.
Haven't seen that forever.
Yep. Okay, and it doesn't matter which one you call y2 and which one you call x2, because I mean, if I put this coordinate over here, that would, I mean, order doesn't necessarily matter. What matters is whichever y you pick first, you want to pick that same x. So for example, I'm going to do the 4, 7 first. So remember, it goes x first and then y. So y2 for me is going to be 7 minus y1 is going to be 2. So again, I subtract my y's on top. And I'm going to subtract my x's on the bottom. And if I pick 7 first, then I need to put 4 first. So these first two numbers need to come from the same coordinate. Just remember, y is on top, x is on bottom. And I'll show you that it would be the same if we did the 3 and the 2. But anyway, 7 minus 2 is 5. 4 minus 3 is 1. So my slope is 5 over 1 or just 5. If we did the other order, so if we did 2 first, it'd be 2 minus 7 over 3 minus 4, which is negative 5 over negative 1. A negative divided by a negative is a positive. So don't leave 2 negatives. 2 negatives make a positive. So you get the same slope regardless of whichever coordinate you put first. The big thing is, like, if I do this y first, then I got to do this x first. And people tend to confuse these, so I'm going to do an example so you at least have this to refer to. Okay, so if we do y minus y over x minus x, if the 0 is on bottom, remember, you cannot divide by 0. That's when math doesn't work. So this is the one that is undefined. This is no slope. This is a vertical line. Flip that around. So say I do y minus, y minus y, and then x minus x. If the 0 is on top, 0 divided by anything is 0. So if the top numbers are the same, okay, if your y's are the same, So your top comes out to be 0. Your slope is 0. Again, that's a horizontal line. So 1, 2, and 3, 2. That graph says a horizontal line. If the bottoms cancel out to be 0, that is your undefined slope. That is your vertical line. So remember 5, -2, and 5, 3. That graph's to make a vertical line. Now, the last thing they can give you and ask you to find the slope is they can actually give you an equation. This is also what ties into 3-3. 3-3 wants us to graph equations, a very easy way to graph. In fact, the way most people learn how to graph and choose this method is to graph using what we call slope-intercept form. So there's a form of the equation. Some of you probably even remember this from Algebra 1. Okay, you might not remember what it means, but you remember y equals mx plus b. This is what we call slope-intercept form. I have terrible handwriting that says intercept. Slope-intercept form. If you get the y by itself, remember I said m is your slope. And this number here, b, is your y-intercept. So if you can get y by itself, like this is, and graphing is really just a matter of counting. So if we know our y-intercept, this is where we're going to cross the y-axis. So +2. So again, my y-intercept is the point 0, 2. Okay, and then my slope is rise over run. It defines the line. So from this point, I would rise 1, run 3. Rise 1, run 3. And that would be my line. So no need to make an XY chart. I don't have to plug in to find my X and my Y-intercept. If you can get Y by itself, graphing becomes just kind of counting. You find your Y-intercept, which is where you cross the Y-axis. Then we use our slope to find 1 or 2 more points. And it's going to be rise over run.
I have a quick question regarding that.
Okay.
So are you the 1/3, the rise over run, are you rising over running from the first point?
Yeah.
Correct.
So the very first thing I did was I plot that y-intercept. So that's from that point. Yes. So from there I rise 1, run 3. So yeah, from that point. Okay. So if they give us an equation not in slope-intercept form, we can get it there. So I want to get y by itself. Okay, we can use our equation tools to get rid of that. So if I want to move this 3x, the opposite of a positive is a negative. So if I subtract 3x from both sides, okay, that makes my 3x go away. I moved it over here. And I put the x first just because I like mx plus b. So, and I can't combine the 3x and the 6 because one doesn't have an x and one does. So they got to stay separate. To get y by itself, I'm going to divide by 2. Move this down. So y is going to equal -3/2 x plus 3. So the -3/2 I went ahead and left as a fraction because it's my slope, rise over run. 6 divided by 2 is 3. It's a pretty little whole number, so I went ahead and converted that. So again, even if you don't start out with y by itself, we can get it there. Now, if they specifically ask me what's the slope, then that's the only number that matters. That's my slope. If they ask for my y-intercept, there's my y-intercept. Now, remember, the y-intercept is a point, so you need to write it like a point. Your y-intercept is always 0, comma, wherever you're going to cross the y-axis. Your x-intercept is always where you cross the x-axis, comma, 0. So your x-intercept is always something, comma, 0. Your y-intercept is always 0, comma, something. So anyway, this +3 means we're going to cross at the point 0, 3. So again, that's going to be my first point. And then again, my slope. So I'm going to rise -3, which means to go down. Then I'm going to run 2. So if I wanted to do it again from that point, I could go down 3 over 2. I actually found my x-intercept 2, convenient enough. So it would have been 2, 0. Okay, so 3-1 is going to be basically kind of making some XY charts and then plotting points and then graphing. 3-4, they're just focusing on slope. Pretty much all of the questions are going to be regarding finding the slope. Sometimes they'll give you the line where you can just count. Sometimes they'll give you points where you'll do the y2 minus y1 over x2 minus x1. So if they give you the line, you can just count. If they give you coordinates, y2 minus y1 over x2 minus x1. If they give you the equation, get y by itself, then the number times x is your slope. Now, they are going to try and trick you with something like this. Don't let them trick you. Okay, this is in slope-intercept form, but you don't see an x. So that means how many x's do we have?
0.
We have 0 x's. When you have nothing, you don't write it down. So just y equals 3 implies y equals 0x plus 3. So what's my slope?
0.
0. So if they just give you a y equals equation, then your slope is 0. If they ask you to graph this, okay, your y-intercept is 3. Your slope is 0. Remember, a slope of 0 is a horizontal line. So the graph of y equals 3 is a horizontal line at a value of 3. So if they just give you a y equals, your slope is 0, your line is horizontal. This is the one that messes people up. What if they just give you an x equals equation?
Wouldn't that be undefined?
That would be undefined. So if they just give you an x equals, okay, then how many y's do we have?
0.
0. Remember, slope-intercept form, y equals mx plus b, I got to get y by itself. If there's no y, I can't get y by itself. There is no y. So this has no slope, or the slope is undefined, or that 0 with a slash. Now, do remember that x equals still gives you a line, just now it's vertical. Because people are so used to algebra and solving equations, they think once you have x, you're done. X equals -2. They forget that you can still technically graph that line, and it's a vertical line, no slope, or the slope is undefined. So don't let the x equals trick you. So if they ask you to graph it, it's going to be a vertical line at that point on x. If they ask you what is the slope is undefined. And I think there's a button for you to click that gives you the undefined symbol. So that's what you're going to want to use. All right, the last thing that they will ask is they may ask you to compare slopes. Okay, parallel lines run side by side. Parallel lines run side by side and will not ever cross because they have the exact same slope. So if a line has a slope of 1/2, pardon, which means it's going to rise 1, run 2. And another line also has a slope of 1/2, meaning it's going to rise 1 and run 2. Then those two lines are going to run side by side forever. They will never cross. Because as this one goes up 1 and over 2, this one's going to do the exact same thing. And they're going to constantly run at the same rate. So they will never intersect. They will run side by side. Perpendicular lines cross, but very specifically, they will cross at a 90-degree angle. Perpendicular lines will have slopes that are opposite and reciprocal. Can't read my handwriting. That's really terrible. R-E-C-I-P-R-O-C-A-L. Reciprocal. Okay. Both of these things are going to happen. Opposite simply means the sign is going to change. One is going to be positive. One is going to be negative. And the quick and dirty way to say reciprocal is they're going to flip. So a line with a slope of 1/3 will be perpendicular. The symbol for perpendicular is kind of an upside down looking T. It's just a shortcut for me to write it so I don't have to write out the word perpendicular. Okay, so perpendicular, if this is positive, perpendicular one will be negative, and it will be flipped. So instead of 1/3, it's going to be 3/1, or just -3. So again, perpendicular, both of those things have to happen. It has to be both opposite and reciprocal. Anything else will be neither of those. So if they ask you to compare, if they have the exact same slope, then the lines are parallel. So 1/2 and 1/2, or -1/2 and -1/2, or 5/17 and 5/17. The exact same slope means those lines are parallel. If they are opposites, meaning one positive and one negative, and they are reciprocal, in other words, they are flipped, then these are specifically perpendicular lines. Anything else is a neither situation, where it's neither parallel nor perpendicular. So if they say, to compare these slopes, okay, are my slopes the same?
Yes.
Are exactly the same?
No.
No, one is positive, one is negative. So they're not parallel. They're not exactly the same. I've got a positive 1/2 and I've got a negative 1/2. Are they flipped?
No.
No. So then this is a neither. They're just two random lines that are going to cross. They are not parallel nor perpendicular. These two lines obviously have the same slope, so they would be parallel. And that's part of 3-4 when they're talking slopes. So that's what we get to cover today. So we covered 3-1, 3-3, and 3-4, not necessarily in that order. Okay, so that was 3 sections in a short amount of time. I am going to publish this and in the Canvas, so you'll have this video under Canvas. So if you need to go back over anything, or if you want to see another example that I did again, it will be there. But if nobody has any other questions, that's all I'm going to cover for tonight. And that's remember, so those 3 sections all have homeworks to be done. You guys get to play around with the graphing using MyMathLab. Yay! Okay, and then next Thursday, we will finish up this unit. We will cover sections 3.2, 3.5, and 3.6. And then we will test after that. So next week, I will talk a little bit more about our test and exactly like how many questions there's going to be, kind of what to expect. And then we'll also talk about how you guys are going to test. So people physically here in Lebanon, you're going to test paper and pencil here in Lebanon. Everybody else will probably have to set up a time with your testing center at your location, either Waynesville or Republic, and you're gonna have to set up a time, like you'll have to make an appointment and test that way. I will talk to both schools and figure out if they want to do it that way or if they want to have somebody proctor. Because like Waynesville, I can see there, is there 4 or 5 of you in there? I think I can see 4 of you guys. Anyway, I might be able to get a proctor that would come in so you guys could test on site right there, but I don't know if that'll work or not. So I'll have to check. But everybody else, you're probably going to have to like call your school and set up a testing time with the testing center, and you'll test paper and pencil. You'll turn it into them, and then they'll get it to me. But anyway, I'll talk about that a little bit more next week. So anyway, next week we finish up chapter 3, and then the following week we will test over chapters 2 and 3. But if you guys don't have any questions, that's all I got. See you guys next week.
Yeah.